Antiderivatives can be best understood as the reverse process of differentiation. So let's look at some examples. If I was to have the function f of x is x squared, if I want to differentiate that and find f dash x, this would be 2x. If I was to have another function g of x, and let's say this one is 4x cubed plus 3x plus 7, and let's say I differentiate this one, I will get g dash x is equal to 12x squared plus 3. Now if I was to take this g dash x, 12x squared plus 3, back to this, then that process is called finding the antiderivative of this function here. Here, same thing. If I was to find a way to get from 2x back to x squared, this is finding the antiderivative of the function 2x. Now, sometimes we might be interested in finding the antiderivative of this function. Okay, so when we're finding the antiderivative of this function, we denote that with a capital F of x. And also sometimes we might be looking for the antiderivative of this function, and that would be denoted with a capital G of x. Now first let's think about how to go from 2x back to x squared. Well, I can see that here I've got x to the power of 1, and that needs to be x to the power of 2. And here the coefficient is 2, and here the coefficient is 1. So I need to think about how to make this 2 into a 1, and this power needs to be raised by another one. So if I was to add 1 to the power and make it x to the power of 2, and then divide the coefficient by 2, I will get coefficient of 1, and I will get x squared. So what I'm doing is I'm adding 1 to the power to make it 2, and then I'm dividing by that. Let's look at this one. So here I've got 12x squared plus 3. Now if I remember, when I differentiated, this is the part that became 12x squared. So here I can see that it's x to the power of 3, and this one's x to the power of 2. So if I was to add 1 to the power and make it 3, then the powers will match. But how do I go from 12 to 4? Well, I can see after adding 1 to the power, making that 3, and then if I divide by that same number, so 12 divided by 3 would give me 4. The 3 here has an x to the power of 0. So x to the power of 0, add 1 to the power, make it x to the power of 1, and divide it by 1, I still get 3. And that will give me 3x. But then I see there's a plus 7 here, and I don't know how to get that if I was here. This could have been a plus 10 as well. This could have been plus 10, negative 5. It could have been any constant here, and I wouldn't know what constant I had when I'm finding the antiderivative. So finding the antiderivative of, suppose, a general function, let's say f of x is x to the power of n. Now if I want to find the antiderivative of this, we've seen that we need to add 1 to the power. So here, if I was to go back and get capital F of x, I would add 1 to the power, make it 3, and then I divide by that. And for these ones, I would have to add 1 to the power and then divide by that new power. So what I do, to find capital F of x, I need to say, okay, x and then n plus 1 here, like we did here. So here we're finding the antiderivative. Like here we went for antiderivative of 2x, we added 1 to the power and then divided it. Here we added 1 to the power and then divided it to get us back to here. And then we realized that this plus 7 could have been something else, and we wouldn't have known because there's nothing here to tell me that there's a plus 7 here. So therefore, when I'm finding the general antiderivative of x to the power of n, I need to add 1 to the power, I need to divide by this new power n plus 1, and I also need to say I'm going to add some constant capital C. Okay, so this is to say that, here I didn't have any idea what this plus 7 might have been. And also this one here, f of x is x squared. If I was to do h of x is x squared plus 3, well, if I was to differentiate that, that would have been 2x as well, and that plus 3 would have been lost. And because of that, when I'm finding the antiderivative, I need to say that I'm going to add c to that. Here I will apply this formula to find antiderivatives, to find the general antiderivative of these three functions. So I've got f of x is equal to x squared, and I'm going to apply this formula here to find capital F of x, which is the antiderivative of it. So capital F of x, so what I need to do is I need to add 1 to the power here. So I can see this is x to the power of n, this is x squared. I need to add 1 to the power, make it 3, and then I need to divide it by 3, or I can say I can multiply it by a third, and then I need to add this constant. So I've got, this is going to be equal to x to the power of 3 divided by 3, add c. Again, instead of saying divided by 3, I could have said times it by a third here. With the next function, you can see that this is addition of some functions as well. So I can see g of x as a function here, add another function, and add another function. When I'm finding the antiderivative using this formula, what I can do is I can find the antiderivative of this bit, and then that bit, and then that bit, and then add them together. And then I also have to say add c because I'm finding the general antiderivative. So if I was to find the capital G of x, so capital G of x, if I add 1 to the power, so x to the power 3, so if I add 1 to the power, make it 4, and then divide it by 4, so that 4 will cancel out, but I'll write that out. So I'm going to have 4x to the power of 4 divided by 4. Here I need to add 1 to the power, make it 2, and then divide it by 2. So I'm going to have plus 3x to the power of 2 divided by 2. Here the power of x is 0, so 0 add 1 is 1, and then divided by 1. So plus 7x divided by 1. And then I need to say plus c. Now you can see this one simplifies. These 4's will cancel out, and we'll have x to the power of 4 plus 3x squared over 2 plus 7x plus c. Let's do this one. So here we got h of x is equal to 2x plus 3 times x take away 5. Now if I expand these brackets, I will then get a function a little bit like this, okay, which we can say are some functions added together, and then I can find the antiderivative of each part. So I can say that h of x is equal to 2x squared. I would need to take away 10x and add 3x, which is negative 7x, and take away 15. And now I can find the antiderivative of this function, because I can say that this function is some functions added together or subtracted here, okay? So we can have capital H of x is equal to, so I will add 1 to the power, make it 3, and then divide it by that. So 2x to the power of 3 over 3. Here I need to add 1 to the power to make it 2, and then divide it by 2. So I need to have, and because the coefficient here is negative 7, I need to take away here. So take away 7x squared over 2. Then we have a negative 15 here. Now here, the x to the power of 0. So add 1 to the power, make it 1, and divide it by 1. So take away 15x over 1. And then I'm going to add c because I'm finding the general antiderivative. Because here, if I was to differentiate this c would go away and it gets lost here. So that's why finding the general antiderivative, you always have to say add c here and add c here and add c here. Now here are some questions for you to practice. So you need to find the general antiderivative of these functions here. And I'd like you to simplify your answers. I didn't do that, but you need to be simplifying your answers.